Welcome viewers, in this video we'll see the solved problem based on the resonance circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. You see the statement of the problem. A constant voltage at a frequency of 1 megahertz is applied to an inductor in series with a variable capacitor. When the capacitor is set to 500 picofarad, the current has the maximum value, while it is reduced to one half when the capacitor is 600 picofarad. So the 1 megahertz frequency is given, inductor and capacitor connected in series, 500 picofarad is the capacitor value. When at the time the current is maximum, the current become one half, reduced to one half when the capacitor value is 600 picofarad. For this we need to find the resistance value, inductance value, Q factor of the inductor. So the given thing is F equal to 1 megahertz, that is 1 into 10 to the power 6 hertz. C equal to 500 picofarad, that is 500 into 10 to the power minus 12 farad. Right. So the F is given. So F equal to 1 divided by 2 pi root of LC by square on the both the side. The C value is given, L value is not given, so that we are able to find the L value from this capacity, from this frequency formula. By square on both the side, F square equal to 2 pi the whole square into LC. Square root of LC, where square it become LC. So F square equal to 1 divided by 4 pi square L into C. What we need is L. So bring the L this side and F square that side. So that L equal to 1 divided by 4 pi square C into F square. Now we can substitute all the values. 1 divided by 4 into pi square, C value is 500 picofarad. 500 into 10 to the power minus 12. And F value is 1 into 10 to the power 6 to the whole square. To the whole square, F square value, so whole square. So by simplifying, what we got, 0.0507 into 10 to the power minus 3 Henry. Right, the L value is calculated. Now we'll go for the next parameter. Let R be the resistance and E be the applied voltage for this given circuit. So at resonance, current I equal to E divided by R. So given that 600 picofarad, the current is reduced to half of the current at resonance. So already 500 picofarad, when it is 600 picofarad, the current reduced to 1.5. So for this case, let Z be the impedance when the current is half at the resonance. Therefore, E divided by Z equal to I divided by 2. So that is equal to 1 by 2 E divided by R. So that is equal to E divided by 2R. Right. So what is the formula here? This basic formula is I equal to E divided by R. So at this condition, I become half of the current. Current become half. So I by 2. So that is equal to 1 by 2 E into R. Right. So this E, the Z can be written as R. So it is E divided by 2R. So this both are same. Z equal to 2R. So in this case, Z equal to 2R. Right. So E by Z equal to I by 2. That's a condition given. But I can be written as E by R. So based on this formula. So this I is replaced by E by R. So that E divided by 2R. So the impedance equal to 2 times of R. So that is the condition we got from this value. At 600 picofarad, current is half at the resonance. Right. So I equal to E by R at the resonant condition. At this, E divided by Z equal to I divided by 2, half of the current. So this I is replaced by E by R because it is resonance, under resonance. So that by comparing this first and last step, Z equal to 2R. Right. Now we'll go for the further simplification. Z equal to 2R by square on both the side, Z square equal to 4R square. We know that R square plus XL minus XC whole square equal to 4R square. That is Z. The basic formula is Z equal to Z square equal to r square plus xl minus xc the whole square. Based on that it is written. Bring this r square that side, so it become minus r square. So 4r square minus r square is 3r square. So xl minus xc the whole square equal to 3r square. We'll take equation number 1. Now we'll find the xc and xl value. Capacitive reactance and inductive reactance. We know that xc equal to 1 divided by 2 pi f into c. 1 divided by 2 into pi into f value is 1 into 10 to the power 6, 1 megahertz. C value is 600 picofarad, 600 into 10 to the power minus 12. At this condition the value is 600. So by simplifying we got 265.3 ohm xc value. Similarly xl equal to 2 pi f into L. So 2 into pi into f is 1 into 10 to the power 6. L value is 0.0507 into 10 to the power minus 3. We already calculated. So by simplifying we got 318.6 ohm. So now calculated XL and XC. Right. From equation 1, XL minus XC the whole square equal to 3R square. Right. Bring the R in the denominator this side. So XL minus XC the whole square divided by 3 equal to R square. Now take the square root on both the side. So R equal to XL minus XC, here square is there, over it become XL minus XC divided by root 3. So R equal to XL minus XC divided by root 3. So XL we calculated 318.6 minus XC is 265.3 divided by root 3. So while simplifying we got R equal to 30.8 ohm. Now we calculated the R value. Now we'll calculate quality factor of the coil. So quality factor Q factor equal to omega naught L by R. One formula is there. Another formula 1 by R square root of L by C. One more formula is 2 pi L F naught divided by R. This is another formula. Now we will use this formula. 2 into pi into the L value is 0.0507 into 10 to the power minus 3 into F naught, the 1 megahertz, 1 into 10 to the power 6 divided by R value is 30.8. What we calculated R value 30.8. So by simplifying this, what we got, Q factor equal to 10.34. So Q factor of the coil inductor is 10.34. So in this problem we discussed the capacitor. The capacitor value is changed from 500 picofarad to 600. At the time current become half of the value. In this we got that Z equal to 2R. At resonance condition only the resistance will be available. So that is nothing but Z equal to 2R. From that we calculated the XL, XC value and R value. Finally we calculated quality factor of the coil. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.